So now we go to the first step, direct conversion transmitters. So very simple. So similar to receiver, we are going to see the transmitter architecture also, but it is going to be very simple because having known about receivers, it is going to be exactly opposite thing, right? So it is going to be direct convert transmitter architecture. So the receiver will consist of LNA and down converter. The transmitter will consist of power amplifier and up converter. It's going to be the exact opposite thing. And you see, I'm going to take the GMSK waveform. I'm going to write the signal like this. And see, the signal has two components, in phase and quadrature phase. So I can write the signal internally as, so take the in phase and quadrature phase, multiply by LO, add it, power amplifier, matching network for the antenna, and then transmit. So you see XBBI into cos omega CT plus XBBQ into sine omega CT. That is going to be your X of t. And X of t is amplified, and matching network will ensure maximum power transfer from your receive transmitter to your antenna, and duplexer will ensure that whatever signal coming from this path will go to your antenna for transmission. So this is called as direct conversion transmitter because it directly converts the baseband signal into RF, high frequency signal. So it does not involve any intermediate stages. So it is called as direct conversion transmitter. And you have power amplifier and matching network to provide maximum power, and the power amplifier has to be linear. So if it is not linear, then it will add its own noise to your signal. So the desired baseband signal is produced to the transmitter. It is going to be only of millivolts, but when it goes into the power amplifier and comes out, it will be in the watts. It will be in the order of watts, or in power, you can say it will be in the order of volt. Signal value will be in the order of volt, or in terms of power, it's going to be in the order of watts. So employing large transistors to carry high current, power amplifiers are going to be we'll be studying about power amplifiers in subsequent units. You will have a lot of power amplifiers, class A, class B, class C. So all these amplifiers are there to amplify your signal, shift the power level for required for transmitting the signal to a larger distance. So among the various architectures available, direct conversion is very simple and it is going to be neat in logic wise. So output will have only the desired signal. It will not have any harmonics or any noise component available. And direct conversion has other issues also, because direct conversion will result in crosstalk. When I and Q are not properly matched, crosstalk may happen. Crosstalk means input of one channel may go into the input of the other channel. This was a problem faced in landline phones. Suddenly, when you pick up a landline phone, you might hear some other people conversing, right? So that is crosstalk. So when your I and Q are not perfectly matched, this results in crosstalk. So that is one of the major issues of a direct conversion transmitter, because we don't have any other frequencies or any other filters involved, right? So we cannot ensure perfect operation. So only when mismatch happens, this will result in crosstalk. Otherwise, it is going to work perfect.